Let's be honest, when you think of the great scientific revolution, your mind probably jumps to guys like Copernicus or Galileo, right? Renaissance Europe. But what if I told you that a huge, absolutely crucial chapter of that story was written 1,000 years earlier, in a totally different language, thousands of miles away? Well, that's what we're talking about today.
Think about this for a second. What if the period we call the Dark Ages in Europe wasn't actually dark everywhere? What if, while one part of the world was in a bit of a slump, another was experiencing a brilliant, shining era of discovery? That single question, right there, unlocks one of the most incredible and often overlooked stories in the history of science.
And for those of you who are new here, hey, welcome to Scholar. This is the channel where we love to dig into everything scientific, cultural, and, yeah, sometimes a little mysterious. Today, we are absolutely pulling back the curtain on a hidden chapter of science history.
All right, so to really get this story, we've got to rewind, way back. We're going back to the ancient world, to a time when our entire understanding of the cosmos, of the universe, was shaped by one single, monumental piece of work.
And that work was Ptolemy's Almagestum. I mean, you can't overstate how important this was. Written around 100 AD, this wasn't just a textbook on astronomy. It was the textbook for over 1,400 years. Its big idea? That the Earth was the center of everything. The sun, the planets, the stars, they all revolved around us. And for centuries, that wasn't a theory. It was basically scientific gospel.
Now here's where history takes this really fascinating turn. Starting around the 6th century, Europe enters what we call the Dark Ages. A lot of that ancient knowledge, including Ptolemy's work, it gets lost, it gets forgotten, but at the very same time, the Islamic Empire was just kicking off its golden age, a period of just unbelievable scholarship and scientific curiosity.
So let's shift our focus and travel east, where a new center of learning wasn't just dusting off old books, they were taking that ancient science and pushing it into the future. Welcome to Baghdad, into the House of Wisdom. Now, this wasn't some dusty old library. Think of it more like a state-funded NASA and Harvard rolled into one. Rulers like Caliph al-Ma'mun poured money into this massive translation movement, paying scholars to find every important book from Greece, Persia, India, you name it, and translate it into Arabic. And when Ptolemy's Almagestum finally got translated, a full 700 years after it was first written, it didn't just get put on a shelf. It lit a fire under a whole new generation of astronomers.
And look at this timeline. This wasn't just a flash in the pan. We're talking about a sustained 500-year-long scientific project. From building the world's first real observatories to discovering new galaxies and developing mind-bending new models of the universe, this was a continuous, unbroken chain of discovery.
And this is where the story gets really good. Because these scholars, they weren't just translators or librarians. They were hardcore experimental scientists. They read Ptolemy, they understood him, and then they started testing his work. They observed, they challenged, and ultimately, they began correcting the master himself. Take the Earth's wobble, for instance. It's a tiny motion called precession. Ptolemy had done the math and said it changes by 1 degree every 100 years. But 1,000 years later, the Egyptian astronomer Ibn Yunus, through just painstaking observation night after night, found a pretty big mistake. He recalculated it to be 1 degree every 70 years. And you know what? He was way, way closer to the actual value we know today. And like Professor Jamil Rajab says, there are just too many breakthroughs to list. I mean, get this. In the 10th century, the Persian astronomer Abdel Rahman al-Sufi was charting the stars. He noted a small cloud in the sky. Turns out, he was the first person to ever record the Andromeda Galaxy, our closest galactic neighbor, hundreds of years before European astronomers even knew it was there.
So, the big question is, how did they pull all this off without modern technology? No computers, no telescopes? Well, it's simple. When the tools they needed didn't exist, they just invented them. And I'm not just talking about physical instruments, but whole new ways of thinking.
You see, these weren't a few hobbyists in their backyards. They worked in massive, state-funded observatories like Moraga in Persia, which was basically a world-class research institute. They built enormous instruments, like giant sextants some 40 meters tall, to make incredibly precise measurements with the naked eye. They perfected tools like the Astrolabe, and crucially, they developed the math they needed to make sense of it all, inventing things like algebra and spherical trigonometry.
But maybe the most powerful tool they forged came from this man, the 11th century genius Ibn al-Haytham. He basically laid down the rules for how to do science. You observe something,
You come up with a testable idea, you run experiments over and over, you analyze the results, and you draw your conclusion. But his most revolutionary idea was that a true scientist must be an enemy of all that he reads. You have to question everything. And that right there, that's the scientific method.
Okay, and now we arrive at the climax. This is where we can draw a direct, jaw-dropping line from a 13th century observatory in Persia straight to the scientific revolution in 16th century Europe. Get ready for this?
So Ptolemy's Earth-centered model, for all its genius, had some clunky mathematical problems that bugged astronomers for centuries. Well, at that Moraga observatory, the brilliant polymath Nasr al-Din al-Tusi came up with this incredibly elegant solution, a mathematical gadget now called the Tusi couple. It was this pure geometric trick that fixed a major inconsistency in Ptolemy's system.
And the evidence of this knowledge was passed on? It's just undeniable. Look at these two diagrams. On the left, that's the Tusi couple from a 13th century Arabic manuscript. On the right, that's from Copernicus's famous book, the one that proposed the sun-centered universe, 300 years later. It's the same diagram. It's identical. Copernicus used the exact mathematical tools that al-Tusi and his team created to build his own revolutionary model of the cosmos.
So what does this all mean? It means the Copernican revolution didn't just appear out of nowhere. It wasn't a sudden rebirth of science from nothing. It was the next chapter in a very long, very international scientific conversation. And the previous volume, the one that made Copernicus's work possible, was written in Arabic.
Now, the coolest part about all this is that the impact of this hidden chapter isn't just stuck in history books. Its legacy is literally written across the night sky for every single one of us to see. That's right. The next time you look up at the stars, you're looking right at this history. Around 200 of the stars we can see, including some of the most famous ones, like Aldebaran, Betelgeuse, and Vega, still have their original Arabic names. They're a permanent tribute to the astronomers who first charted them all those centuries ago.
So, this legacy is really all around us. It's up there in the star names and the names of craters on the moon. It's in the fundamental tools of science itself, like algebra and the experimental method. But most importantly, it's in the foundational knowledge that formed the essential, critical bridge that connected the ancient world to the modern one.
It really makes you wonder, doesn't it? Science isn't the story of one person, or one culture, or one time period. It's a long, winding, interconnected human conversation. And it just makes you think, how many other hidden chapters of that story, of our shared journey of progress, are still out there, just waiting to be rediscovered?
Hey, if you enjoyed uncovering this hidden piece of history with us, do us a favor and hit that like button. Make sure you subscribe to Scholar for more deep dives like this one, and definitely check out the sources in the description below if you want to learn more. Thanks so much for watching.